Okay, hello and welcome everyone. In this video, I'm going to do an overview, kind of a reminder of optimal pricing for a single price monopolist. And then I'm going to think about actually estimating the demand curve and how that might work via experimentation, historical data, and then ultimately surveys. All right, so we'll start off with this recap of optimal pricing. And our question we have really is like, what does the demand curve for the product look like, especially if it's a new product or something where we haven't previously been able to investigate. Later on, we'll think about advanced pricing. So this will be primarily price discrimination, first, second, third degree price discrimination, and then also bundling and two-part tariff pricing schemes. So that's yet to come. This is the outline of the next couple lectures. And then I'll do something for intertemporal pricing. This would be the type of thing where we have to worry about what's going to happen to our demand over time. If consumers would switch to us from rivals or vice versa, if there's learning by doing or stuff like this. And so this is all yet to come. For today, we're going to think about optimal pricing, and then we're going to think about what does the demand curve look like and how we'd even begin to answer that question. So our optimal pricing technique for a firm with market power, actually any firm, is going to be they're going to produce where their marginal cost is equal to marginal revenue. It's actually true for any firm because the competitive firm is going to look at their cost curve. They're going to find where marginal cost is equal to the market price. That's the output that they're optimally going to produce, assuming that price is higher than their average variable cost associated with that quantity. Now, for a firm with market power, of course, they're going to, like a monopolist, they're going to produce where their marginal cost is equal to their marginal revenue if they're charging only a single price, right? So if there's no price discrimination. So we're thinking of a situation where we have monopoly. There's no competitors or substitutes that are responding to the prices. And, lots of times we'll use our market power analysis here for situations where you haven't maybe got necessarily a true monopoly. You've just got a firm that's facing a downward sloping demand curve and is therefore able to choose either the price or the quantity, and then demand adjusts. So this could be something like Apple, who has a monopoly over a particular subset of iPhone users, right? So iPhone's not the only smartphone. There's a lot of different options. However, there's some people that are very devoted to their iPhone, and they're going to buy any iPhone that Apple makes. And over those people, Apple maintains a monopoly. You could think of the Venn diagram of consumers, right? Those who would buy only the iPhone, those who would only buy something else, I don't know, Android, and then those who are kind of in the middle, and they're going to be a little bit more price sensitive. We apply our monopoly model thinking about those for whom consumers believe there's no reasonable competitors or substitutes. So that's what I mean here. We're thinking of monopoly, although there is some flexibility. The main thing is we have firms who are able to influence their price. We're assuming demand and costs are constant over time. Is that a good assumption? I mean, I don't know, right? Because in the midst of a pandemic, we have the situation where there's a massive increase in demand for some things, massive decrease in demand for other things, right? Massive increase in demand for Zoom and other teleconferencing technologies, massive decrease in demand for cruises, right? What about costs? Well, I mean, that's not constant over time necessarily. Even apart from issues with the pandemic, right? You have a situation where maybe you're able to innovate, right? Maybe you're able to come up with a way to lower your costs, maybe by virtue of expanding your scale of operations. If there's economies of scale, costs are falling. But our basic assumption, our simple model, is making these assumptions. We want to articulate these assumptions and realize those are the limitations of this model, right? Like if those assumptions fail to hold, that's a severe limitation. We want to be aware of those. We want to think about how we'd have to tweak those assumptions and adjust the model to be more appropriate with whichever is the situation we're actually dealing with. But for now, I just kind of want to give us an overview, kind of a reminder of optimal pricing. So I'll do this with a numeric example. Suppose we have the following demand curve. Q is equal to 100 minus P. The way that economists would typically draw this is actually solved for P. We'd actually graph the inverse demand with price on the vertical as the dependent variable, quantity on the horizontal as the independent variable. Nevertheless, it's the same relationship, of course, right? And so you can see how that would work. Sometimes it makes sense to work with demand. Other times we want to work with inverse demand, which is just the same relationship then solved for price in terms of quantity. We're assuming constant marginal cost, constant average cost of 10. This is going to give me a cost curve that's just a horizontal line at a height of 10. And my question is, what decision maximizes profits for the firm? So what's the monopolist deciding on? Are they choosing quantity? Are they choosing price? Are they choosing both price and quantity, or either price and quantity? Well, the way that we framed it, the way that we'd be writing this, we've got demand in terms of price. We'd actually maybe have this monopolist choosing price. Typically, the way we solve the problem, the way that I'm going to demonstrate, is we have the monopolist choosing quantity. Of course, the answer is the monopolist can choose either the quantity or the price in any given situation. They can't choose both. Why not both? Well, consumers have a say in the matter. So either you choose the quantity and the price adjusts, or you choose the price and the quantity adjusts, because consumers can decide not to buy. All right, so let's think of the firm deciding on quantity, because this is sort of our standard MR equals MC solution for the monopoly, right? So we have profit. Economists like to use pi for profit because we use P for price. Total revenue minus total cost, so price times quantity minus marginal cost times quantity. I've replaced price with price in terms of quantity, right? So now I've written profits only in terms of quantity. 100 minus Q, this is actually the inverse demand curve, times Q, that's this quantity here, and then minus 10Q. If I distribute this and then subtract off this 10Q, right, collect like terms, this would be 100Q minus 10Q is 90Q. Negative Q times Q is Q squared. And then I'll take the derivative to maximize profits, right? So this is going to be 90 minus 2Q, because the derivative of this with respect to Q is just the constant. It's just 90. The derivative of this, you bring the exponent in front, reduce the power by 1, and so this will be 2Q to the first. That's this right here. Now, alternatively, you might remember that the marginal revenue curve, we can always back out. Marginal revenue will have the same slope, the same vertical intercept, but twice the slope as the demand curve, as the inverse demand curve. That's this, although it doesn't look like it. The reason why is because I've already subtracted off my marginal cost. And so if I would have just taken this, if I just kind of done what's highlighted, that would be the revenue side. So total revenue is 100Q times, or 100Q minus Q squared. Marginal revenue is therefore 100 minus 2Q, right? This is 90Q because we subtract off our 10Q, which is capturing total cost, and then our 10 ultimately, which is our marginal cost. All right, so we have maximized profit. The profit maximizing quantity is 45. To find the price, remember, prices come from demand curve. So I have to go back up to my demand curve and then find the associated price. So price is going to be equal to 100 minus Q, or price is equal to 55. And so we've done this right here. Now, alternatively, I could have done this with the firm choosing price. So you write out profits as a function of P, take d pi dp, find the optimal P, then go to the demand curve to find the optimal quantity. And that would be this. You'll get the same result, right? You should stop the video. You should verify for yourself. You get the same result. It's good to do that at least once and be comfortable with it. Here's the graph of this problem, right? So we have the inverse demand we have price on the vertical, quantity on the horizontal. The inverse demand has a vertical intercept of 100, horizontal intercept of 100. Marginal revenue has the same vertical intercept, but twice the slope. So it's actually going to cross at 50. And then this right here is going to correspond to the midpoint of the demand curve, 50 and 50. It's not this. This right here, this box is actually the monopoly's profit maximizing quantity and the profit maximizing price. If the midpoint here is at 50, this tells us indeed this is on the elastic portion of the demand curve. The elastic portion is further up the demand curve, inelastic at the bottom. And we remember, monopoly is never going to want to produce on the inelastic portion of the demand curve, because that would correspond to a negative marginal revenue. Marginal revenue is already 0 here, and for the marginal revenue down here, it's negative. But that's just sort of an aside. Anyway, so here is the picture corresponding to the monopoly's optimal quantity and monopoly's optimal price. Now here's the more general derivation. So if we get away from the numeric example. To maximize profit, we're going to take d pi dq just as we did. Here's profit written in terms of quantity. So this is price as a function of quantity. That's what we had. To take this derivative, this is going to be like the product rule. So derivative of the first times the second plus derivative of the second times the derivative of the first times the second plus the second times the first times the derivative of the second. It's just like, how about I just look at what I've done, right? So I'll take the derivative of this. This is d pi dq. This q comes along for the ride for the first part. Then I'll take the derivative of this with respect to q, and that's going to be a 1. This p is going to come along for the ride. I've suppressed this p of q notation here just because I didn't want it flying around. I've realized, apologize, this looks like I'm going to use Newtonian notation for my calculus derivative, and here I've got Leibniz notation. Let's just go with the Leibniz notation because it goes away really quick. So anyway, here's the derivative, and then the derivative of total cost is just marginal cost. Now what I've done, and for the purposes of the class, you want to follow what I'm doing here. You're not going to have to reproduce this. That's not a good question for economics of entrepreneurship. Here we're interested in the application. I'm just showing you where this is coming from and why it'll be valid for us to use this ultimately. Okay, so here I'm going to isolate price minus marginal cost. This is the margin. This is the markup, right? This is the price. This is the marginal cost. This is going to be the per unit profit that the firm is going to get. Now, this part I've moved to the other side. So it's going to be a negative dp dq times q. That's this right here. All right, now I'm going to build something. I'm going to divide both sides by p. And this is kind of cool because stare at this on the left for a while. That's the markup divided by the price. That becomes a percentage markup, right? Percentage markup. If we take the markup and divide the markup, the amount by which price exceeds marginal revenue divided by the price gives us the percentage markup. On the right-hand side, this should look familiar. This looks a lot like the elasticity formula. If you go on my search, if you Google on my YouTube, if you go on search and type in point elasticity formula calculus, it'll show you the point elasticity formula for calculus, or for the calculus version of the point elasticity of demand, price elasticity of demand in point elasticity form. That's this right here. Well, it's the inverse of this right here. And so the price elasticity of demand formula for calculus version boils down to dq dp times p over q. Well, this is dp dq times q over p. So this is the reciprocal of that. And so I have written this as percentage markup is equal to this minus 1 over eta. Eta is standing in for my price elasticity of demand, right? And so I'm just recognizing this, putting this in, and this now has a really cool interpretation. This is telling us the percentage markup is going to be related to the price elasticity of demand, telling us basically the more elastic is the demand, the less the price can be above marginal cost. The more elastic is the demand, the more responsive consumers are, the more alternatives they have, right? The more alternatives that they have, the more substitutes and competitors they've got to respond to your pricing with. And so the more elastic is the demand, the smaller the markup has to be. I mean, in the limit, right? Perfect competition has zero markup. The more inelastic is the demand, the smaller is eta. Inelastic is like close to zero. It's like less than 1, right? So that's inelasticity. So the more inelastic is the demand, the fewer alternatives, the fewer close substitutes there are for consumers, and the higher the markup can be. So that's all this comment is saying. All right, so now what I've just done is good. This is like our starting point, but what if we don't have our demand curve? We have to build it. So especially for new products, we might need to build our demand curve. We could use market experimentation. I'll talk about that. We might be able to use historical data. That's questionable. It might not be applicable in all cases. And we could probably use consumer surveys. That'd be generally the recommendation. The basic idea with market experimentation is let's set a bunch of different prices in a lot of different markets and then see what consumers do. So set different prices in different time periods. So you could change your price every couple of weeks or every month or so. You could set different prices in different places, either real or virtual. Now, there's some problems with doing this, right? If you set a lot of different prices in different time periods, consumers aren't going to be so happy about that, probably. One of the ways that firms are able to change prices without kind of annoying consumers is through discounts and like codes and stuff like this that effectively change the price without actually adjusting the sticker price. So consumers tend to tolerate coupons and discounts expiring a lot better than prices rising. All right, the other thing is, well, you could set prices in different places, but now we've got this worry about are those consumers the same or different? And so I'll talk about that a little bit. Here's a simple example for how the market experimentation might go. So my simple example is a pet sitting service. Suppose we have our marginal cost as maybe gas and wages, $15 per visit, and I'm going to set a couple different prices. So on the Old West Side, $25 per visit, Burns Park, $20 per visit. And this is a real example. Like I get a lot of mailings in my mailbox, or I guess like with the newspaper box, from high school students that are offering to give Puppy Study Break a walk, right? So here's my puppy. And so there's a lot of interest, at least in my neighborhood, for pet sitting. Why? I mean, it's probably pretty easy. So for those who are entrepreneurial inclined, and for those who have a lot of time flexibility, it's actually not a bad side business. And it's probably if I was in high school, I'd rather have a pet sitting service than like cutting lawns or something. I don't know, maybe not. Kind of depends. But anyway, so it's a pretty reasonable thing for kids, and we've got a lot of kids. And so there you go. All right, so suppose we were trying to determine what should be the optimal price. okay, set the price in Old West Side at $25 per visit, set the price in Burns Park at $20 per visit, and here's what happens. 200 visits per week are demanded in Burns Park, 200 visits per week in the Old West Side. We can calculate this and then determine what the profits are for each, and it looks like the $25 per visit is going to be the more profitable, right? 25 minus 15 is our 10 times our 200 was our 2,000, right? So it looks like that was our more profitable. It's certainly bigger than 1,250. So that's pretty good per week. I was working in an amusement park when I was in high school and college, and that was $5.61 an hour, which is, I should have done pet sitting, I guess, or I should have time machined myself into 2020. Before the pandemic. So anyway, analysis suggests that $25 is the better price. Can we do better here? So let's try linear regression analysis. The idea is, hey, we've got two data points. Let's find our line of best fit. Well, it's 2 points, so it's pretty easy. I mean, you could take these ordered pairs and you can determine the slope between those lines, and then with the point slope formula, you can back out the equation for this line right here. If you had more data, you'd do regression analysis using a statistical package. You'd want to estimate the intercept. This is the intercept, the fixed component, and then this is the per unit component. This is the slope, right? And so this is like y equals mx plus b form. This would be like the b, this is like the m, this is like the x, this would be like the y in this case. And so, you can estimate our demand curve. Economists, econ majors would probably use data. Business majors probably use Excel. I don't know. So we don't have enough data to do that. We actually don't need to. We can just plot these points, and then we can go ahead and chart what's going to be this line. So our linear regression results here would be 450 minus 10p. Good. And then if we were to work through the profit maximization problem, which I encourage you to do, you find that the optimal price is going to be $30. Fine, but there's actually a couple problems there. First off, this recommendation of $30 as our profit maximizing price was generated using data that did not involve $30. So we should be suspicious. Right? If you've taken the econometrics class, or when you do, you'll realize that there's actually kind of a substantial issue there. You don't want to extrapolate the data beyond what you've been able to sample. So the other thing we might worry about is unobserved factors. So here we're assuming that the only difference between the two regions was the price. That's probably a bad assumption, right? So population might be different. Population's a demand shifter, number of buyers. Income's a demand shifter, right? Depends, do you have a normal or an inferior good? Number and prices of competitors might be different, right? Substitutes and complements. So we'd have to control for these other demand factors, otherwise we can't trust our results. So to do this, we'd want to use multiple regression analysis. We'd want to be able to collect data. We'd want to be able to directly control for population and income. And if we do that, once we've estimated beta naught, beta 1, and beta 2, beta 3, we'd be able to state that this is the partial slope. This is the partial effect. This beta 1 is the effect on quantity of changes in price after controlling for population and income. Truthfully, the interpretation of beta 1 is a 1 unit increase in price is associated with a beta 1 increase in quantity, would be our interpretation here. I say associated rather than caused by because we have to do quite a bit more to identify a causal effect. That's another topic for the econometrics class. All right, so there's kind of problems here. That's a lot of data to collect. We might not have it, and there's different types of issues, but we can get around this. Suppose we were able to make our own controlled random experiment. So suppose we were able to randomly assign different prices to different customers. This allows us to eliminate concerns about unobservables. So suppose we have 10,000 customers coming to our website, clicking through a banner. We give 5,000 of them one price, 5,000 another price. And if we're randomly assigning them, then we don't have to worry as much about these unobserved factors. A law of large numbers should guarantee that our first group is going to look essentially the same as the second. And you'd want to check this, right? You'd want to collect any other data that you're able to about those two groups of 5,000 and make sure the means, at least, of those data points look exactly the same. So for instance, approximately the same, whatever information you'd have, like age, zip code, these sorts of things. You wouldn't want any massive differences in terms of like the proportion using one operating system, one browser or another. Famously, obviously there's the case of the bargain-seeking hotels website that was showing the more expensive hotels ranked higher, ranked more prominently for those accessing with a Macintosh rather than those with a PC. They'd see the same results if they clicked all the way down through there, but they gave priority to the more expensive hotels. And as we know, people don't very often click further down the results. And so we'd want to make sure that, we want to control for things like we want to control for the ways in which we'd be able to infer if the two groups are different. We want to take a look and make sure that the data look approximately the same. If we were to do that, if we were convinced that the first group is the same as the second group for all practical purposes, we've got 2 points on the demand curve. We can draw a line through those points, and we're a lot more confident in those 2 points in that line than we would just from our simple experiment. So obviously, more data points are going to give us more statistically reliable results. I mean, with more data, we're going to get smaller standard errors. If you've taken the econometrics class, you know what that means. If you haven't, you should take it. The econometrics class is one of the most important classes you take in the econ major. All right, so one of the issues you might have would be arbitrage across markets. You want the markets to be super separate. The problem would be, what if I give a discount to one person, they turn around and sell to somebody that didn't get a discount? That's arbitrage, and we want to be able to avoid that situation. Otherwise, it'll contaminate our experimental results. Another issue might be if we have nonlinear demand curves, or if the relevant portion of the demand curve is nonlinear. Now, we typically model demand with this nice downward sloping demand curve. That's not really what demand looks like. It's close enough. It's not very often for the relevant portion of our demand, it's going to be downward sloping and approximately linear. That's something you want to investigate. You definitely want to make sure you don't have an upward sloping demand curve. Now, that sounds ridiculous. It violates the law of demand, but you can have like Veblen effects. You can have network externalities. If you have status seeking effects where raising the price actually over a particular region leads to a higher quantity demanded. And so weird things can happen. You'd want to kind of look at the data and make sure that those aren't going on. And this is actually one of the reasons why you're doing this exercise in the first place, right? The other issue, well, you want to be careful about extrapolating your demand curve too far from your sample data. So we just talked about that. Our data points were 20 and 25 were our prices. And then here it told us the optimal price was 30, which is ridiculous. So we want to do more investigation. Another issue is you don't want to spoil your demand, which is like upset consumers because you've changed the price too many times, or they perceive that you're doing an experiment. The other issue is like it's difficult to be able to control for what the competitor's doing. So we ultimately want to be able to estimate the cross-price elasticity. We want to include in our multiple regression results how the competitor's price is going to affect demand for our product. We want to be able to control for the competitor's price. What you'd probably be doing is taking their average, taking the long run average price or something like that, or whatever data you've been able to collect, but you can't manipulate the competitor's price, obviously. So that's a problem. So we can't typically experiment with our competitor's price. So that's a limitation here. With historical data, so if we're getting away from experimentation, with historical data, you could do similar regression analysis with past data. And so one of the big things you want to do is you want to think about what was the origin of that data set. How is it collected? What are the definitions of each of the variables, especially if you're pooling or merging data from a variety of sources? You want to know what the data are doing and what it's showing and what it's not showing. And this is always actually best practice if you're using somebody else's data or data that you've acquired that you haven't actually collected yourself. And you should document the data that you collect so those coming after you within your firm or outside or wherever would be able so that they could use the same data set and then not be misled. There's a lot of other problems with historical data, problems of endogeneity, and even more of a problem identifying a causal effect if you don't have a natural experiment to be able to exploit. So these are interesting issues to think about. This would be like the common statistics and econometrics class 1. This is the intermediate level. This is the advanced level. And so these are different types of issues that you'd be exploring in some of those courses. All right, so now I want to think about consumer surveys because this is getting us a little bit closer to what people would actually be wanting to do. So what you can do with surveys is you can put your consumers through a series of hypotheticals, and then they'll tell you what they would purchase and what their purchase intensity would be. And if you do this correctly, you could use regression analysis to be able to estimate a demand curve. And I say correctly, you want to make sure you write good survey questions that aren't leading, such that the survey itself is going to be invalid. But there's some advantages to surveys. In particular, you don't necessarily need multiple markets, right, as you would for experimentation, right? You can try a lot of different hypothetical prices on consumers in a single market. You can randomly assign those hypothetical prices to different groups, right? you can get pretty reasonably reliable data with a relatively small amount of surveys. You'd want over 100, right? And more is better because you'd have smaller standard errors. And then from the standpoint of surveys, well, now you can hypothetically list what your competitor's price would be. You can assess other marketing decisions you might care about, like packaging and other types of price, like a membership fee or something. We'll talk about two-part tariff later in the course. The big thing is you can estimate demand prior to entering the market. So this is a way to determine are consumers as in love with your product as you are. Like, are consumers gonna be as interested in purchasing whatever is this product as you believe them to be? And that's good to do. You want to estimate your demand before you put in, buckets of money without knowing if there's going to be a return. Problems. Do consumers make different decisions in hypothetical situations than in reality? I remember in high school giving bizarre, sort of off the wall answers to the different types of surveys that would come across us. And in general, this can be a really big problem for a variety of reasons. You can have people just kind of messing with the survey. You can also have people who are intending and have pure motivations and want to answer truthfully, but they're just wrong, right? They say what they're going to do, but that's different what they actually do, or for a variety of reasons. They might not be intentionally misleading. It's just different when you're asked, will I pay $15 a week or $15 a visit to have my dog walked? That's different than, am I going to do that now, right? And so there's some problems with surveys. There's also some selection problems. There's the issue of, are your respondents representative of your customer base? Like, are these going to be the same consumers who you're going to be selling your product to ultimately? And so you want to make sure that you've targeted your survey to your likely customers. Always want to think about the selection issue. And there's related issues. So I'll talk about a lot of different types of surveys. Telephone, in-person, national, global product will have online surveys. Probably you'd want to do online surveys for most products. I would think that's probably going to be the most efficient, and it's going to be probably the easiest to work with that data. You could do mailings, right? So like the prospective dog walkers in my neighborhood, they've done mailings. Those aren't surveys, but sometimes you might get a mail-in survey and be asked to return it. There's selection bias there because not everybody's going to be motivated to send that mailing back. And that can be difficult to deal with. Telephone's a similar way. Like, it's cheap to call people. You can call a lot of numbers in a small amount of time. The problem is there's a massive selection issue, right? So like, who's going to answer the phone? I don't use my phone for anything. I don't answer my phone. I'll check my voicemail and then send an email back, but I don't use my phone, right? Like, who uses their phone, and who answers a number that they don't know? So there's a problem. The people who do, the people who say yes, are very different than the people who don't. And so there's a selection issue there. Also, over the phone, it can be difficult to get the idea across just because it's difficult to be able to describe something without pictures, and the person you're talking to might be super distracted. So there's that issue as well. You can do in-person interviews. That's good. You might even be able to get near to the people that you'd want to be selling to. Like, if your customers are going to be on a college campus, you can survey on a college campus, on the mall. Or you can go to a literal shopping mall and you could survey if you're going to end up be setting up mall kiosks or something, right? So you can go to the area where your customers are going to be. That's good. A little bit easier to get your idea across. You can have pictures. You might have good selection in the sense of where you've chosen to do the survey. Problem is, this can be really expensive. It's time consuming. You're going to have this massive opportunity cost of your time or whoever's going to do it for you, and then you're compensating them monetarily. And then there's the issue of interview bias. Like, sometimes people answering the survey for an interviewer right there are going to be influenced by the fact that the surveyor is right there, right? So these are all reasons why online surveys are probably a good idea. You can get pretty far reach for pretty low cost. There's a lot of good ways to do surveys. There's some other problems, like you want to be aware, cognizant of the relevant selection problems. You can do like Facebook ads, or you can do Instagram or something like that, and then sometimes you can target a little bit better, but even there's some selection problems, and there's some products for sure this isn't going to work well on. I spend a lot of time, tonight I'm going to be on my treadmill running for a couple hours, and late night TV is selling products to a very specific demographic that you're not going to reach with an internet survey, right? So you want to think really carefully about what's going to work well for your product. And there's a lot of cool entrepreneurial activities that can add a lot of value to that population. But you want to think really carefully about who you're trying to reach and if your survey is going to reach them through that medium. In terms of assembling your survey, you want to think about a way to be able to identify who are going to be your relevant consumers. So you want to screen out your irrelevant consumers. Ask questions like, do you even have a pet? And if no, well, their responses aren't as valuable. Maybe they're not valuable at all, right? And then pricing, so you want to think carefully about your pricing questions. So for instance, you could say the cost of our pet sitting service is $30 per visit. Are you going to do it? That's not bad. It's not a good idea to ask the same person a lot of different prices. Like, hey, will you buy it $30? What about $25? What about $20? Or what about $20, $25, $30? I mean, there's a problem because there's this sort of contamination. There's these anchoring effects. And so that's an issue. One alternative is you could say, well, what would you be willing to pay for this particular service? And then you're eliciting what their willingness to pay is. And that's sort of a good idea. Another thing you can do is you can ask about intensity. How often would you use this service? And you can ask a variety of other things you'd be interested in. So you could think about varying your competitor's price. If their price is X, ours is Y, which will you buy? You could think about varying your product design. You could think about your advertising copy, which is advertising copy is the literal verbiage that you're using in the advertisement. Usage questions are really important, such as for Zipcar. You want to know, am I putting this product in an area where people are going to use it and use it enough so that we're not leaving this capital idle? But you definitely want usage questions and purchase quantity type questions. All right, so here's an example. Suppose, in thinking about how we'd actually analyze the survey data, suppose we have these questions to 400 screened pet owners over the phone. So we know we have a pet. Then we say the cost of our pet sitting service is P per visit. Would you use this service? And then how many times per year would you use this? We'd use 4 different prices, 20, 25, 30, 35, and we'd have randomly selected 100 respondents to reach each of these prices. Now, since they've been randomly selected, on average, the groups should be similar. We can make comparisons across those groups. 100's a little bit, it's sort of like the threshold for how large we'd want it to be. Probably, if you could do it, you'd want it with bigger, but okay, fine. The randomization allows us, though, to be plausibly convinced that the unobserved demand factors just won't be relevant. Suppose our results are these. Group 1, who saw the price of 20, 40 people said yes with an average quantity of 15. Suppose group 2 saw 25, 30 said yes, 30 people said yes with an average amount of 16, so on and so forth. We can estimate a demand curve, right? So think about our price of 35. This is going to be a price on the vertical. Quantity on the horizontal is going to be 170 for this point. 10 people said yes, they're going to use it 17 times on average. That's 170. So that's how I plotted these points. 170, that was 17 times 10 associated with the price of 35, and so on and so forth for my other data points, right? So we've got this. A couple things we can do here. We can plot our line of best fit, and then we can use that as our demand curve. And then if we have a large amount of data, we could compute profit actually at those points, and then whichever is the highest, indeed, that's going to be our profit maximizing point. I wanted to just skip over it. So here, this is our demand curve per 100 customers. If we wanted the overall demand curve, multiply the quantities by n over 100. So then some things about how you'd scale up this to the larger overall demand curve, right? This is a demand curve per 100 customers. We want to think about the demand curve overall. All right, fine. This is kind of a technical slide. And so anyway, so if we have a large number of customers, rather than having to do that and scale up and get our overall demand curve, you could just plot the profits at each of these pairs. There's going to be a little bit of error there, obviously. The true profit maximizing price might be higher than 30, might be lower than 30. But, so we probably expect, if anything, it might be a little bit lower. This looks like it's tailing down. I don't know. We could be heading towards a peak, and then there could be a precipice. I don't know. You don't know until you do it. But this is telling us this is our profit maximizing price, and this is kind of reinforcing the idea we had from before. The last thing I'll say in terms of estimating demand curve is companies are doing this. Companies are doing a really good job of collecting data and seeing what people buy and at what prices. Amazon, for sure, they see what prices you've viewed and which products you've actually purchased. There's an interesting paper that was mentioned in Freakonomics with one of the Freakonomics co-authors, Stephen Levitt. You could go to Google and find the Freakonomics Uber estimating demand paper. There's an NBER, National Bureau of Economic Research version that should be a working paper version you'd be able to get. And anyway, it talks about how they used Uber data to estimate the demand curve for Uber, right? People see the price, they decide whether to buy or not buy, if it's surging or not surging. And if you take an Uber, or if you don't, we're able to determine your willingness to pay and estimated demand curve. And they used the paper. One of the findings was there's a massive amount of consumer surplus, the difference between their costs and the price and the willingness to pay of consumers, generated by Uber, which is what we'd expect. We'd expect it's adding quite a bit of value for customers. The other interesting thing from the Uber paper and from that Freakonomics podcast is they were talking about how they realized if consumers' battery was dying on their phone, they had low cell phone battery time, their demand was much more inelastic, much more unresponsive to price. People were far more likely to take the price during surging or take high prices in general when they had very little time left on their battery. I mean, obviously, you're not going to be able to find the substitute, which is getting a non-Uber ride. And so they say in the podcast that they're not actually doing anything with that data. But anyway, it's interesting, like all the data that in some sense terrifying, but interesting, all the data that's available to firms and in terms of estimating consumer demand and thinking about consumer behavior. There's a lot of interesting aspects of behavioral economics, which, at some point I might weave into the courses. That is an interest area, an area of research for me. But anyway, I really hope you enjoyed the video, and I will see you next time.